Hey everyone, welcome back to Mathematical Learning. And today we're going to be looking at SMO Junior round 2. This time it's from 2011. This is a special round. And we're given this problem. Given that the sum of n positive integers is 16 and the sum of their reciprocals is 1, find all possible values of n and solve this equation for that value of n. Okay, so first we're going to transform equation 1. In case you remember, x1 plus x2 plus xn is 16. So we can say that x1 plus x2 xn over n, which is the arithmetic mean, is equal to 16 over n. So now we can take the second equation. And we have 1 over x1 plus 1 over x2 plus 1 over xn equals 1. So from here we can say that 1 over this entire thing is also equal to 1. Now multiplying by n on both sides, we get this equation. Now in case you didn't know, this is called the harmonic mean. Harmonic mean of these n numbers, and this is called the arithmetic mean, which you probably already know. So now the harmonic mean, there's an inequality which I might prove in a later video, that the harmonic mean is always less than the arithmetic mean. So the harmonic mean is n, arithmetic mean is 16 over n, so we can say that n is less than 16 over n. And multiplying by n on both sides, since n is positive, we can do that. We get n squared is less than 16, or n is less than 4. Oh, sorry, less than or equal to, because the harmonic mean, arithmetic mean, harmonic mean inequality says arithmetic mean is greater than or equal to harmonic mean, and the arithmetic mean is only equal to the harmonic mean when all the numbers are equal. So n is only equal to 4 if x1 equals x2 equals x3 equals x4. Right. Alright, so now what can we do? We've constrained the value of n a lot, and since n has to be a positive integer, the only cases we have to test out is n equals 1, n equals 2, n equals 3, and n equals 4. So for n equals 1, obviously that means x1 is 16 and 1 over x1 is 1, which is obviously not true. So n equals 1 is out. There. Now n equals 2, we have 1 over x1 plus 1 over x2 equals 16, and x1 plus x2 is 16. Actually, sorry, no. 1 over x1 plus 1 over x2 is 1. Silly me. Alright, is 1. Now we can simplify this by making the denominator the same, and we get that x1 plus x2 over x1 x2 is 1. So multiplying by x1 x2, we get x1 plus x2 equals 16 equals x1 x2. Now you can check the factors of 16, but if you check the factors of 16, you'll find that this equation has no integer solutions. No integer solutions. So n equals 2, out. Now what about n equals 3? So n equals 3. Firstly, we have x1 plus x2 plus x3 is 16. So by using the pigeonhole principle, we can say that 16 over 3 plus 1 equal to 6. So we can say that 1 of x1 of x1, x2, x3 is greater than or equal to 6. So without loss of generality, let's assume that x1 greater than or equal to 6. So it means 1 over x1 less than or equal to 1 over 6. Alright, that means from the second equation, 1 over x1 plus 1 over x2 plus 1 over x3 is 1. We get that 1 over x2 plus 1 over x3 is greater than or equal to 5 over 6. Now, the greatest possible value of this is 1, where x2 is 2 and x3 is 2. But then 1 over x1 would be 0, which is impossible. Hence, the next smallest value is x2 equals 2, x3 is 3, right? Like I said, the next biggest value. And this 1 over 2 plus 1 over 3 is equal to 5/6. So it satisfies our equation. It satisfies the inequality. So we have 1 over 2 plus 1 over 3. If the sum of this is 5/6, that means x1 equals 1 over 6. But if we take 2, 3, and 6 and add them up, this is not 16. This does not satisfy our first equation. Hence, n is not equal to 1, n is not equal to 2, n is not equal to 3. That means n must be 4. But remember how I said if n is 4, then x1 equals x2 equals x3 equals x4. So we can apply this condition, and we can, so that means since they all sum up to 16, x1 equals x2 equals x3 equals x4 equals 4. And this also satisfies our second equation. So now, in summary, we can conclude that the only value of n is 4, and the solutions for n equals 4 is this. Alright, I hope you enjoyed this video. If you did, don't forget to subscribe and share with your friends. And if you want to receive notifications for more videos like this, you can also hit the notification bell. As always, thanks for watching.